Alright, these are acid-base problems. The way I've got these set up is I've kind of got them into groups. Let's get it. And you can see here we've got 16 and 17. They both refer to the same reaction. What we're looking for are the ions that will make up compound A. Not only that am I going to find the ions, which is all you really need to answer the question, but I'll go ahead and I'll show you how to do the complete problem as well, because you'll need to know how to do that anyway. We definitely need the ions though in order to figure out what compound A is going to be. Alright, so we'll start out, we'll have NaOH plus H3PO4. And since this is an acid-base problem, you know that what's going to happen is this. We know that the OH is going to join with the H over here. That'll form water. And then we'll have the Na joining with the PO4 over here. Now the secret to all of this is making sure we just take one of each ion over here to figure out what's going to combine with what. So we've got a sodium here, so I'll bring that over. I know that the sodium will combine with the PO4. Understand though that here I've just got one sodium, but here I've just got one PO4 group, not 4 POs or anything like that. Remember, the 4 only refers to the oxygen, and this PO4 is its own entire group, and it's just one of those right here. If there was more than one of them, there would have been parentheses or something else around it to tell you how many there were, but that's not the case here. So what we're looking at here is just one PO4 group. Alright, so going back over here, and here's the important part. We've got one OH over here, and that's going to combine with one of the hydrogens here. Now I know there's 3 H's here, but I only want to take one of them, and if I take an H plus and I take an OH minus and I join them together, what am I going to get? I'm going to get H2O. So that's how I'm getting the H2O over here as well. So in all of these acid-base type problems where you've got an acid, that's the thing that's giving off the H plus, and you got the base, that's what's giving off the OH minus. When those things add together, you always get a water and what's called a salt. Now we're still not done yet, and we still haven't even answered the questions yet, but this is where we're at this particular point. The next thing we want to do is figure out what kind of compound we're getting over here from the Na and the PO4. Alright, so we know that the charge on sodium is 1 plus. I can prove that because if I know that the OH is 1 negative, that means the sodium over here has to be 1 plus. Alright, so over here I can say Na and OH. If I know OH is negative, I can get that off the polyatomic ion sheet, and then this one's going to be plus. So that means that that will balance out. So that's Na plus over there, and over here we've got H3PO4. Now we know that PO4 has a 3 negative charge, and we already know that H will have a positive charge, but you can see that if we have 3 H pluses, that's going to give a total charge of 3 plus there, and a total charge of 3 minus here, so you see that balances out. Alright, so if that charge is PO4 3 minus, that'll go up here, and this becomes the answers to what we were talking about. So these are the two ions that we're looking for, Na plus and PO4 3 minus. Alright, so what we're going to do is we're going to go ahead and continue this problem, even though that we technically answered it. And what we're going to do is we're going to join those things together and figure out what kind of compound we're going to get. Alright, so I'm going to rewrite this NaOH plus H3PO4. Now I've got to ask this question. If I've got Na plus and PO4 3 minus, how am I going to combine them together in order to get a neutral compound? Alright, so here's what I do. I've got Na plus, I've got PO4 3 minus. If I look at my total negative charge, you can see I've got a negative 3 charge. I know I'm going to need a positive 3 charge over here, so the question becomes, how many of these am I going to need to balance that out? Well, what it means is I'm going to need a total of 3. So Na plus, Na plus, Na plus, so a total of 3. That will give me 3 plus, that'll give me 3 minus, and you can see that everything's going to balance out. So the compound now becomes Na3PO4. That's actually my compound A. Now, in addition to that, I can go ahead and balance it. And what sometimes annoys people here is they say, well, look, you got three sodiums here. How do you have three sodiums? You only had one over here. Well, that's because I haven't balanced the entire reaction yet. Up to this point, all I've done is balanced this compound, which is the salt. Alright, so now I can go ahead and balance the compound. I've got three sodiums here, so I'll put a 3 in front of here. And I've got one PO4, so I've got one PO4 here. And I want to really concentrate more on the oxygens because the hydrogens appear in two different places, so it's better off doing the oxygens. There's a total of 3 oxygens here. Remember the PO4s were already handled, so we've got 3 oxygens here, so I'll put a 3 in front of here. That's going to leave me with 6 hydrogens over here. Now what I want you to see is there's 3 hydrogens plus 3 hydrogens, that's 6. So that's now balanced out. Alright, so that's how we do 16 and 17, and we should get the answers of Na plus and PO4 3 minus for those. Alright, so in the next one we've got CaOH2 plus HCl. Again, what we're going to see is the Ca will join to Cl and the OH will join with the H. So what we'll do is we'll do Ca, we'll do Cl over here, and then we'll have H2O. Now remember, the H2O comes from the joining of H plus and OH minus, and that's going to give us our H2O. Now remember, all I'm doing here is just taking one H plus and just one of these OH minuses. Only one. It's really important I just take the one. Alright, so let's go ahead and continue this. I want to now put some charges on these. Now I know that CaOH2, if I draw it out, it's going to look like this. Each OH has a -1 charge. Total charge is -2. That means that the total positive charge has to be +2, which means calcium will be 2+. Now over here with the Cl, I've got Cl will be a -1 charge. So now we can go ahead and balance this out. Balance out the Ca2 plus and the Cl minus. So that'll be CaOH2 plus HCl will give CaCl2. So the question I was asking myself here was, if I've got Ca2 plus and Cl minus, how many of each do I need in order to get a balanced compound? Well, I've got 2 plus, which means I need 2 of these Cl negatives to balance it out. That's why it becomes CaCl2 here. If you want to look at a picture of what that looks like, it would be Ca2 plus and then Cl negative and Cl negative. And you can see that all balance out, -2 and +2. And that's plus H2O. Now we can go ahead and balance out the entire reaction. And you see we've got 1 calcium, 1 calcium. We've got 1 Cl and 2 Cl, so what I'll do is I'll put a 2 in front of a Cl here. We've got 2 oxygens, so I'll put a 2 in front of the water. Remember, I don't really want to deal with the hydrogens because they appear in so many places, at least not yet. Now I can look at the hydrogens. I can see I've got 2 hydrogens here plus 2 hydrogens, that's 4. 2 times 2 is 4, so those hydrogens are balanced as well, which means the entire reaction now is balanced. Alright, well, just to finish this problem off, we've got Ca2 plus and Cl minus, so one of the ions would be Ca2 plus and one of them would be Cl minus.